So good morning students. Again I welcome you all for another lecture on the course of Computer Architecture and Organization. In today's class I am going to discuss about another important topic, which is addressing modes. This is a very important topic for your examination point of view as well as for future learned courses. So my request is please carefully listen the class. Okay, so here my topic is addressing modes. Fine. What is an addressing mode? First, what is an addressing mode? And what is the use of an addressing mode? And what are the different types of addressing modes? These things I am going to cover in this lecture. Fine. So first we can see what is an addressing mode. An addressing mode is nothing but the way in which the data was represented in the operand field of the instruction. I repeat once again, the addressing mode indicates the way in which the data was represented in the operand field of the instruction. We know that in every instruction have an operation code field as well as an operand fields. The operation code indicates what is the operation we are going to perform, and the operands indicates the data information. So here important thing is how we are going to represent our data in the instruction itself. Sometimes we can represent our data directly in the instruction. Sometimes we represent our data with the help of some register, and sometimes we represent our data with the help of a memory location address, and sometimes we represent our data by the combination of registers, and sometimes we represent our data with a combination of a register and a memory location like this. So finally, what the way we are using for representation of data in the instruction operand field, that can be indicated by an addressing mode. I repeat once again the definition: the way in which the data was represented in the instruction operand field, that's what we can call is an addressing mode. I can say in another way, it is like this: the different ways in which the location of an operand is specified in an instruction is called as addressing mode. So finally, what an addressing mode is, what is the way we are using for representation of data in the instruction operand field. That's the meaning of an addressing mode. Next, what is the use of this addressing mode? Why we have an addressing mode? One thing you have to remember, friends, if you refer any processor or any microcontroller, definitely it will support certain number of addressing modes, because each and every instruction belongs to certain addressing mode. So that's why each and every processor or every controller definitely supports a good number of addressing modes. Let's we can see what is the use of this. The first important thing is the addressing mode creates a flexibility to user to implement an application program in different ways. What is the meaning of this? For example, guys, I would like to add a 20H with 30H. I would like to add a 20H with a 30H. If I give this assignment to different students, they can make the application program with the help of assembly language instructions. But the thing is, what are the programs they make? All those programs will not be same. It means in terms of the number of instructions what they are using for making of that application program, it differs. Why we are getting different solutions for a same problem? That is only because of this addressing modes. That's why here we clearly says that the addressing modes creates a flexibility to user to implement an application program in a different ways. So that is the use of that. And next thing, already I told you that every CPU supports a good number of addressing modes, because every processor or CPU have a certain instruction set which consists of a group of instructions, and every instruction definitely belongs to certain addressing mode. So that's why each and every processor or a controller supports a good number of addressing modes. Especially here we are talking about the machine language or assembly language instructions. Once you refer every CPU or every processor instruction set which is in assembly language, no doubt the instruction must belongs to a certain addressing mode. So that's why each and every processor or controller supports a good number of addressing modes. So what our conclusion? So what is the advantage of this using of addressing modes? The addressing modes creates a flexibility to user to implement an application programming at different ways. That's the use of this. Fine. Next we can go and see what are the different types of addressing modes. So here I just mentioned total 10 different addressing modes. Some of the addressing modes are present in some of the processors, and some of the processor may support all these type of addressing modes, and some of them we can go and add some additional addressing modes. But out of all this, these are the 10 different addressing modes we frequently observe in different processors as well as controllers. What is the 10 different addressing modes? The first one is immediate addressing mode. This is the first one. This is immediate addressing mode. And the second one is direct addressing mode. Third one is register addressing mode. Fourth one is register indirect addressing mode. Fifth one is indexed addressing mode. Sixth one is based with index addressing mode. Seventh one is based with index addressing mode along with an offset. Eighth one is relative addressing mode. And ninth one is auto increment addressing mode. And 10th one is auto decrement addressing mode. These are the 10 different addressing modes we regularly used in our processors. That means these type of addressing mode based instructions we observe in the instruction set of any CPU or any processor. Fine. Now we can go and discuss these addressing modes one by one. First, my discussion starts with immediate addressing mode. So which instructions we can call as immediate addressing mode based instructions? If I want to call an instruction which belongs to immediate addressing mode, what that instruction must have? If you are thinking that direction, I can say like this: in this immediate addressing mode related instructions, the data was directly placed in the instruction operand field. I repeat, in this addressing mode related instructions, the data was directly placed in the instruction operand field. And here one more thing you have to remember, especially this operand is source operand. Especially this operand is source operand. I repeat my statement regarding to this immediate addressing mode is, in this addressing mode related instructions, the data was directly placed in the source operand field of the instruction. So for this I can give an example: move hash 2000h comma 20h. In this example, this hash 2000. So this 2000 indicates an immediate value. To indicate this is the data, for that I prefix hash symbol. And here the numbers always we are using in hexadecimal form, that indicates this h. You remember friends, in our computers all the numbers are generally represented in terms of hexadecimal values. We already know why we are going to use hexadecimal values. Generally in your digital systems we are using a binary numbers. It is very difficult to remember the bit combinations of all the informations which are in binary. In order to simplify that, we took the help of hexadecimal notations. So that's why in every processor or a controller, the numbers are represented in hexadecimal form. Fine. Here the meaning of this example is move hash 2000h comma R0. The meaning of this one is simply transfer the immediate value 2000h into one of the CPU register, which is register R0. So that is the meaning of this. In this case, where I am placing my immediate value, I place my immediate value at the source operand field. This is your source operand field, and R0 is your destination. So what is the meaning of this immediate addressing mode is, I clearly tell you that in this addressing mode related instructions, the data was directly placed in the source operand field of the instruction. So that condition satisfied in this example. And next, the meaning of this is this. Fine. So the next second addressing mode is a direct addressing mode. This direct addressing mode we can also call as absolute addressing mode. Don't confuse the friends. In some of the textbooks, they didn't write a direct addressing mode. Instead of that, they are going to write absolute addressing mode. You remember, this is also called as absolute addressing mode. absolute addressing mode. So how I can identify this direct addressing mode related instructions? In this addressing mode related instructions, so this addressing mode is also called as absolute addressing mode. Absolute addressing mode. It is not direct. Right, fine. So in this addressing mode related instructions, the address of the data was represented in the instruction operand field. What happens in the previous case? In previous case, that means in previous addressing mode, I can directly place my data in the source operand field. Instead of directly place data in the operand field of the instruction, in case of this direct addressing mode, I can go on to place the address of the data in the instruction operand field. So here I write that address of the data was represented in the operand field of the instruction. So in this case, we can create somewhat security compared to previous case. Because in a previous case, right away I can go and identify what my data was. But coming to direct addressing mode, there is no such chance for me. If I know the data, only when I can go and access the address of the data. That's the important one. And the next one is the example of this is move LOC comma R2. Move LOC comma R2. That means move the content of memory location LOC into CPU register R2. So here LOC is nothing but some memory location address. If I go and access that location, I may get the data. So that data is a transfer to the CPU register R2. I hope you understand the difference between this and previous one. In previous one, in place of this LOC, there we have hash 2000H. Because in previous case, I can place directly my data in source operand field, but now instead of writing this data directly in the instruction itself, I copy this data first in a memory location, that location address placed in instruction operand field. So due to this, we increase somewhat the security of our data. So that is, so the same thing I written here. It means transfer the content of memory location LOC to the processor register R2. Then where we are using this? That's the important thing. So this addressing mode represents global variables in a program. Out of the global variables, if you want to represent in a program, for that particular case, we took the help of this direct addressing mode and related instructions. What is the meaning of this global variables? The meaning of this one is these variables can be used in any program which you are making for that particular processor or a CPU. So in order to define those global variables, I took the help of these direct addressing mode instructions. That you have to remember, friends. And coming to fourth one, that is register direct addressing mode. This is the third one. So in this addressing mode related instructions, the data was represented in the instruction operand field through a register. So here I write like that. So the data was represented in the instruction operand field through a register. What happens in previous case? We are representing our data through a memory location address. Before that, we are representing directly data in the instruction operand field. But now, we are representing our data in the instruction operand field through a register. I can say in another way, if you are observing any instruction which may have both the source and destination operands, both are CPU registers, no doubt such instruction also comes under a register addressing mode. I repeat once again, if you refer any instruction, that instruction both the source and the destination operand fields both are registers, no doubt that instruction also comes under this register addressing mode. And one more thing, sometimes this same register addressing mode instructions we can also call as register direct addressing mode instruction. That means this register addressing mode is also called as register direct addressing mode, because directly we are writing our CPU registers in the instruction operand field. So that is the meaning of this. So see here an example for it. So move R1 comma R2. So the meaning of this is move the content of CPU register R1 to another CPU register R2. So I'm already told you, if an instruction have both the operands, that means source and destination, both are registers, no doubt that instruction is comes under this register addressing mode. Generally this addressing mode defines the variables in the program. That means a register and direct addressing modes are used to represent our variables in the program itself. That means whenever if you want to declare some variables in your program, we took the help of either register addressing mode or direct addressing mode related instructions. I already told you in the previous case, that is in order to declare global variables in the program, we took the help of a direct addressing mode based instructions. In a similar way, to represent or to declare the variables in your program, then we took the help of either register addressing mode or direct addressing mode based instructions. I hope you understand the difference between immediate addressing mode, direct addressing mode, and then third one is register direct addressing mode or simply register addressing mode. Next, I shifted to the fourth one, that is register indirect addressing mode. Generally, this is the combination of previous two. What the previous two? Previous two addressing modes are, one is a register addressing mode and second one is a direct addressing mode. Fine. It is a combination of those two. So, in this addressing mode related instructions, the address of the data was represented in the operand field of the instruction through a CPU register. That's important. The address of the data was represented in the instruction operand field through a CPU register. What happens in direct addressing mode? The data was address of the data was directly represented in the operand field. What happens in register addressing mode? The data was represented in the instruction operand field through a register. But now what we can say is, the address of the data was represented in the instruction operand field through a CPU register. That means in this particular case, I can provide some more extra security for your data. I didn't get directly data if I access a register. If I access a register, just I was getting only the address of the data. By taking that address, if I move to the concerned location, then only I can get my data. So by using this particular addressing mode, I can increase some more security for my data. So if I take an example for this, move in brackets of R1 comma R2. So it is somewhat similar to previous one, register direct addressing mode. The difference between this and that one is, here we are using these braces. If you are using a braces, that indicates this register didn't contain a data straight away, it contains the address of the data. I can give a clarity for this. If I take an example, this register R1 have a value some 2000H. Yes, we can assume. This 2000H is not a data. It is an address. So, for example, this is our memory. This is our memory. This is the that address 2000H. So, this 2000H contains a value some 4000H. Now, your data is this 4000H. So, the meaning of this particular instruction is, move the content of R1 specified location data. R1 specified location is 2000. What the 2000 consists? 4000 data. That 4000 was a transfer to another CPU register R2. I simply write like this. The content of that is 2000H was a transfer to CPU register R2. So generally here this 2000 is nothing but an address which is available in register R1. That means in order to execution of this instruction, first I can go and access the CPU registers. In that I can go and access the content of register R1. Then I can get the address of data. By taking that address, I can move to the memory location. I'll go and access the location whose address is 2000. In that location, I have a data. I bring the data, and the data is a transfer to another CPU register. So see here, guys, I furtherly increase the security of my data. Fine. Next, so the meaning of that one I can mention here. So here another important thing is here from this onwards we talk about effective address. From this onwards we talk about effective address. So what this effective address is? Simply in our textbooks we observe a notation EA. EA means effective address. What is the meaning of that? Effective address means the final address of a data or the final address of operand. So the final address of operand or the final address of a data is called effective address. So what is the effective address for this register indirect addressing mode related instructions? In this register indirect addressing mode related instructions, the effective address is nothing but the content of a register. In previous example, my example is move in brackets of R1 comma R2. For that case, effective address is equal to the content of R1. What's the content of R1? According to our example, the content of R1 is nothing but a 2000. That 2000 we call as effective address. You remember friends, effective address means the final offset address or the final data address or the final operand address is called effective address. From this addressing mode onwards, we are talking about this effective address. It is very important to us. All of you remember effective address means the final address of data or the final address of operand. So that you have to remember. Fine. The next one is index addressing. This index addressing mode is somewhat similar to register indirect addressing. But only the difference here is along with our register we will go and add some displacement value. The displacement value is also called as constant value or it is also called as offset value. I can say about this index addressing mode like this. In this addressing mode related instructions, the address of the data was represented in the instruction operand field through the combination of a CPU register and a displacement value. This displacement value also called as a constant value. In sometimes the same thing we can also call as offset or simply offset address. I repeat what this index addressing mode. In this index addressing mode related instructions, the address of the data was represented in the instruction operand field through the combination of a CPU register and a displacement, or a CPU register content and a constant value, or I can say a CPU register content and an offset value. So then for this case, how we are getting this effective address? The effective address of an operand I can calculate by simply adding of the register content with the displacement value, or I can say in another way, I can calculate effective address by adding of a register content with constant value, or I can say in another way, I will get effective address of my data or of my operand by simply adding of a register content with the offset address. I have a different relations that you have to remember. Next is like this. This index addressing mode symbolically I can represent like this x of Ri, where here this x represents or this x denotes the displacement value or constant value or an offset value. So here this what it represents? It represents a constant value. We know that the constant value we can also call as displacement value or we can also call as an offset value. So here x represents or x denotes a constant and Ri denotes a name of some CPU register. So then how we are getting an effective address? I already told you, just by adding of a constant value or a displacement value or an offset value to the content of a CPU register. By adding of this, I may get a final effective address. We may get a more clarity by observing this following example. Example is add 220H in brackets of R1 comma R2. So see here guys, in previous case, in this source operand field, just we have only one operand. But now here what happens? In the source operand field, we are observing a register along with some constant value which is at 20H. So that means here I can go and calculate an effective address like this. For this particular case, effective address of my operand or effective address of my data is equal to 20H plus the content of register R1. Then I was getting certain location. I took an example. For example, before execution of this, the content of register R1 is again some 2000H. You can assume like this. Then the effective address is equal to displacement value, that is at 20H, plus the content of register R1, which is at 2000H. Then final effective address is equal to 20H. That means in order to get my data, I can go and refer a memory location whose address is 2020H. That location data is adding with the content of a CPU register R2, the result again stored in R2 itself. I hope you understand what this index addressing mode is. You remember in this index addressing mode related instructions, the address of the data was represented in the instruction operand field through the combination of a CPU register and a constant value. Fine. I can go for another addressing mode. So another addressing mode is base with index addressing mode. In some textbooks, the same thing we can also call as base and indexed addressing mode. So what's the difference between this and previous one? In previous one, we have one register holds some part of a data address, and another part we are directly placed in the instruction cell as a displacement value. But coming to this case, what I have to do is, we didn't write directly the address of data in the instruction itself. Instead of that, what we are trying to do is, whatever my data address, that can be split into two halves. One half can be held in a base register and another half can hold in an index register. Both are again the CPU registers. So here I can say like that. In this addressing mode related instructions, the address of data was represented in the operand field of the instruction through the combination of base and index registers. Both are the CPU registers, guys. Both are the CPU registers. So in this case, I am not writing directly out of my data address in the instruction itself. Instead of that, I can copy that value into another CPU register. So I clearly told you that based index addressing mode like this. In this addressing mode related instructions, the address of the data was represented in the instruction operand field through the combination of base and index registers. Fine. Then how do you calculate effective address for this? Simply adding of base register content with index register, then you may get an effective address of your data. Fine. Next we can go and see an example of this. So here effective address is equal to like this. Effective address is equal to in brackets of Ri plus in brackets of Rj. Just you can assume this. Ri denotes base address, so base register. Ri denotes base register and Rj denotes index register. What I already told you is to calculate an effective address simply by adding of base register content with index register content. Just I was getting an effective address. I took an example here. Add R1, add in brackets of R1, in brackets of R2, comma R3. The meaning of this one is go and add the content of R1 with R2 to get a final offset address of a data. The data is added to some R3 content. I took an example. For example, R1 have a value 2000H and R2 value some 3000H. Then what I have to do is, first I calculate effective address of my data. How I was getting this? By simply adding up base register content with index register content. Base register value is 2000H plus index register value is 3000H. Then final address is equal to 5000H. Now what I am doing is, I will go and access the memory location whose address is 5000. That 5000 data is going to adding with, this is some x, I am assuming this x value is added to a CPU register R3, then the result is copied onto again R3 itself. So this is what the base indexed addressing mode is. I hope you understand what is the different addressing modes. I already discussed immediate addressing mode, direct addressing mode, register addressing mode, register indirect addressing mode, indexed addressing mode, and then base indexed addressing mode. Thank you.